Good morning, students. Let's start with the further discussion of the chapter Analytical Chemistry. The topics that we have already covered are colors of the salt and their solutions and action of sodium hydroxide solution on certain metallic salt solutions. And in today's topic, we are going to cover action of ammonium hydroxide on certain metallic salt solutions. So in this, what we are going to do, we will be taking salt solution, any salt we can take, like FeSO4, that is ferrous sulfate, ferric chloride, zinc sulphate, etc. We need to make solution of it. We need to dissolve that salt into water and make it solution. And then we will add ammonium hydroxide to the salt solution. And what we'll get is metal hydroxides will precipitate and a salt will form. And the second step that we need to carry out is the metal hydroxide and the salt that we have got, we will further add ammonium hydroxide. That is, we will do excess addition of ammonium hydroxide and we can get any of the one observation. That is, we can get a soluble complex or the metal hydroxide will not dissolve. So these are the two observations that we can observe. Let us first take the example of the salt FeSO4, that is ferrous sulfate. In ferrous sulfate, when we add ammonium hydroxide, Fe combines with OH and form FeOH whole twice, which is an insoluble precipitate, and the salt that is formed in this case is ammonium sulfate. So in this case, what you can see in the first test tube, FeSO4. The color of ferrous sulfate is light green in color. When we add ammonium hydroxide to it, the color becomes dirty green. The precipitate, that is ferrous hydroxide, is dirty green in color. And if we add excess of ammonium hydroxide to this solution, we find that the precipitates of ferrous hydroxide are insoluble. Let's discuss the next one, that is FeCl3. FeCl3 means ferric chloride, Fe in +3 state. Now in this, when we add ammonium hydroxide, we get FeOH whole thrice, that is ferric hydroxide precipitates and ammonium chloride is formed as a salt. The solution of ferric chloride is yellow in color. So remember this, when FeCl3 is dissolved in water, the color of the salt solution is yellow. But when the precipitates are formed, they are reddish brown in color. And in this case also we get the same observation. If we add excess of ammonium hydroxide, the precipitates of ferric hydroxide are insoluble. The next one, let us take the example of the salt, that is copper sulfate. We can take any salt of copper. In this case, we have taken copper sulfate. So in copper sulfate, when we add ammonium hydroxide, precipitates of copper hydroxide are formed. Copper sulfate, you can see in the first test tube, it is blue in color. The salt solution is blue in color. When the precipitates are formed, they are pale blue in color. Okay, and along with the salt, that is ammonium sulfate. Now to this solution, that is test tube 2, if you add excess of ammonium hydroxide, you get deep inky blue solution. Okay, so there is a formation of a complex, that is tetramine copper 2 sulfate and along with water molecules. When the precipitate dissolves, and the coloration which we obtain is deep inky blue color. Okay, so we need to remember that copper hydroxide color is pale blue and the soluble complex which is formed, that is deep inky blue. So in excess addition of ammonium hydroxide, precipitates of copper hydroxide are soluble. The next one is zinc sulphate. Salts of zinc are colorless, or we can say they are white. When they are dissolved in water, the solution is colorless. And when we add ammonium hydroxide to it, we get the precipitate of zinc hydroxide along with ammonium sulfate. And what we find is, when we add excess of ammonium hydroxide to it, the precipitates of zinc hydroxide dissolves. So they are soluble in excess, as that was in the case of copper also. Now the last one is, let us take the example of lead nitrate. In lead nitrate, when we add ammonium hydroxide, we get white PPT of lead hydroxide along with ammonium nitrate salt formation. Now you can see here white precipitation of lead hydroxide, and to this solution if we add excess of ammonium hydroxide, we observe that the precipitates are insoluble in excess of ammonium hydroxide. So in today's lecture, students, you have studied that how the precipitates are formed with ammonium hydroxide, their color and their solubilities. And we need to remember that the precipitates of copper and zinc are soluble in excess of ammonium hydroxide and rest all are insoluble. Okay. Thank you so much.